In the first part of Lecture 3, we related the enthalpy change to a heat transferred to or from a system at constant pressure. Here in the second part of Lecture 3, Lecture 3b, we're going to do the same thing for internal energy and heat transferred not at constant pressure, but at constant volume. All right, let's do this. Okay. So, what we want is, what we're going to do is to start from the first law of thermodynamics and show that delta U, the internal energy change, can be calculated as the heat transferred at constant volume. We contrast this with delta H, which we did in the first part of Lecture 3, is QP, constant pressure, here constant volume. And we're going to use the same procedure that we used for enthalpy. For that enthalpy, we started with the definition of enthalpy. But we don't really need to do that. We just use the first law of thermodynamics. Let's write the first law of thermodynamics in differential form. du is equal to dq plus dw. Or remember, in the integrated form, delta u is q plus w. But let's use the integrated or the differential form here. Well, we're going to make the assumption that you can only do PV work. So in that case, from our definition of PV work, this is minus P dV. And now, as usual, we'll make some sort of simplifying or assumption or constraint. Let's do a constant volume, V, and that means that dV is equal to 0. So this term goes to 0. And this is just equal to dQ. And we'll call this constant volume. This assumption here going from there to there was only PV work. Okay, so there we have it. I mean, that wasn't too hard. Now let's integrate this, the integration du. We'll integrate this, dq, again, V at constant volume. This is a state function, so we can write this as delta U. Another way to say that is du is an exact differential. And we know that q is an inexact differential, so there's no delta there. We'll just say the integral is qv, the total heat transfer to the constant volume process. So there it is. Just like delta H is qp, delta U is qv. All right, so far we've looked at enthalpy and free energy changes. Enthalpy and internal energy changes. And we're going to continue in the next part of this lecture to look at those changes in enthalpy and internal energy. That's it. Nice quick second part of Lecture 3.